Hello friends, welcome back to my YouTube channel. In this lecture, I am going to discuss about the energy analysis of unsteady flow process, which is also called a variable flow process or transient process. And this topic is such a topic in which most of the students find great difficulty, and in some cases also teachers also find difficulty in handling this topic. But in questions are often asked in GATE exam from this area, so we must study this subject and try to have a grasp over the conceptual clarity as far as this topic is concerned. So before starting, I must say one thing to all of you. Please do subscribe to this channel. Of course, like it and share it to your friends. So why this? First of all, we must know why this unsteady flow process is difficult to analyze. First thing, क्यों ये इतना आसान नहीं है. So first thing we must know, steady flow process. In steady flow process, what happened? Steady flow process, obviously any kind of flow process means it is applicable for open system or control volume, and in steady flow process the analysis is simpler because there is no change within the control volume. Suppose this is the control volume. Control volume is nothing different from open system. So suppose this is your control volume and this is its boundary. Control volume means obviously there must be some mass interactions. So that means mass must be coming in or mass must be going out of this control volume. This is control volume. And steady flow process is simple because there is no change within the control volume at any point of time, because no property of the control volume, be it intensive or extensive, changes with respect to time in case of steady flow process. Steady means invariant with time. So that's why that analysis is a bit easier as compared to that of unsteady flow process, क्योंकि कंट्रोल वॉल्यूम में कुछ भी चेंज नहीं होता है. मास ऑफ द कंट्रोल वॉल्यूम डज नॉट चेंज ड्यूरिंग दैट प्रोसेस. Even energy of the control volume also does not change during that process. So no change occurs within the control volume in case of steady flow process, thus making the analysis a bit easier. But the case here, unsteady flow process, is different. Unsteady flow process में some changes can occur within the control volume. We must keep track of the changes that occur within the control volume in terms of mass and energy. Both mass and energy content of the control volume may change with respect to time. एक इंस्टेंट पे जितना मास अगर सीबी में कंट्रोल वॉल्यूम में होगा, सम टाइम आफ्टरवर्ड्स इट में चेंज. एंड एनर्जी कंटेंट ऑफ द कंट्रोल वॉल्यूम मीन्स अनस्टेडी फ्लो प्रोसेस में दोनों चेंज हो सकता है, बोथ मास एंड एनर्जी कंटेंट ऑफ कंट्रोल वॉल्यूम. सो एनर्जी कंटेंट मतलब total energy of a system. We have already studied energy of a system is Ek plus Ep plus U. This is kinetic energy, this is potential energy, this is molecular internal energy. And in most of the cases these two terms are absent because ये तो move नहीं कर रहा है. And potential energy can be also change in potential energy is often neglected because there is no this is stationary system. So that's why E is equal to U. Whenever a system is stationary means change नहीं होगा कुछ potential, neither potential energy nor kinetic energy. So that's why energy content of a control volume can be approximated to U. E can be, most of the times E can be considered to be equal to U, molecular internal energy. So in case of unsteady flow process, mass and energy content of the control volume may change. So we have to keep track of that. That makes the analysis a bit difficult. So what are the examples of unsteady flow process? Examples are like charging. So these are the examples. What are the examples? These are the of examples of unsteady flow process, like charging of a rigid vessel from supply lines. Then discharging a fluid from pressurized vessel, driving a gas turbine with help of pressurized air, stored air, जो एयर कुछ भी कंटेनर में स्टोर होके रहता है प्रेशराइज्ड एयर में. And another common example is inflating tires or balloons. So these are the common examples. Charging and discharging are the most important problems that are often asked in the exam. Charging and discharging. In case of charging, some mass of fluid enters and no mass leaves the control volume. Only mass enters the control volume. And in case of discharging, fluid mass only leaves the control volume, but no mass enters. And inflating tires or balloons are examples where the control surface changes. That means shape of the control volume changes. So that is also a big difference between steady flow and unsteady flow process. In steady flow process, there is neither. So this is one of the important difference between steady flow and unsteady flow process is that in case of steady flow process, there is no change in space, size and shape. But in case of unsteady flow process, no change in space, but change may occur in size and shape. जैसे कि हम जब बैलून और टायर को इन्फ्लेट करते हैं तो उसका जो बाउंड्री होता है वो एक्सपांड हो जाता है. दैट मीन्स बाउंड्री वर्क जो while discussing about steady flow energy analysis we concluded that there cannot be any boundary work present in case of steady flow system or steady flow process because volume remains constant. We know that boundary work is nothing but integral of PdV. Since volume is constant in case of a steady flow process, then how can there be boundary work present? But in this case, there can be boundary work. That is also an important difference. So boundary work can be present. That's an important point. in unsteady flow systems or process. Unsteady flow process. Along with shaft work along with shaft work and electrical work. In case of steady flow process, boundary work is not possible. Boundary work is totally absent. But in case of unsteady flow process, there can be boundary work along with shaft work as well as electrical work. In the expression that we derived, that the steady flow energy equation that we derived, we found that WCB only represents the shaft work or electrical work. But in this case, we can also include boundary work because the volume changes in this case. Boundary moves here. So there may be change in size and shape. Maybe usually the space usually there may not be change in the space. That means the systems are stationary most of the cases, but shape size change hota hai in case of unsteady flow process. This is an example of charging. In case of this is the supply line. This is the supply line. This is a rigid vessel, and fluid enters into this control volume and no mass leaves, and this is an example of charging. So broadly, the unsteady flow process problems are divided into two types. One is charging and another is discharging, and very often in exams questions are asked either from charging or from discharging. This is an example of charging, where fluid enters from a supply line to a rigid vessel, and whatever pressure temperature is the fluid is having in the supply line will not change with time. Usually it does not change with time, and it can be assumed to be constant with time because this is a large supply line. Means it's a large volume. There is a large volume of fluid, so that's why we can assume that the properties do not vary with time. So this is an example of unsteady flow process. So now we'll derive the energy balance equation. Energy balance equation के लिए we know that there are two principles on which energy balance equation is derived. In case of steady flow process also we did that on the basis of principle of mass conservation, and another principle is principle of energy conservation. So this is principles of mass balance. फर्स्ट मास बैलेंस को यूज करेंगे एंड एनर्जी बैलेंस प्रिंसिपल को यूज करके हम एनर्जी बैलेंस इक्वेशन फॉर अनस्टेडी फ्लो प्रोसेस we will derive. So suppose this is your CV and this is control surface. Suppose some mass is entering into the control volume M in, and this is M out. Another difference is that since no property of the control volume in case of unsteady flow process change with respect to time, we deal with this analysis in terms of a finite period of time. Steady flow processes occur continuously over a long period of time. On the other hand, unsteady flow processes occur for a finite period of time. That's a big difference between the steady flow process and unsteady flow process. Steady flow process continues for a long time period, but unsteady flow processes occur for a finite period of time, that is for suppose delta t period of time. For a finite period of time this unsteady flow process occurs, and once that period is over, that process is completed, and there is that means the process finishes after a finite period of time, finite time period, suppose delta t. So that's why it is better to make an analysis over that finite period of time rather than per unit time period, as we do in case of steady flow process. In steady flow process we analyze in terms of per unit time. Mass balance and energy balance equation, whatever we derived steady flow energy equation, in that case we took the mass flow rate and energy flow rate into account. But in this case we can make the analysis over a finite period of time rather than per unit time period. Analysis we can take both mass balance and energy balance can be analyzed for a finite period of time rather than per unit time period. So that's why suppose mass balance will be m in minus m out will be, according to the principle of mass balance, is equal to delta m of Cv. Suppose 15 kg over a finite period of time, 15 kg of fluid enters into a control volume, out of which suppose 10 kg leaves the control volume. Then 15 minus 10, that is 5 kg, contribute to the increase in mass of control volume. In this case, this delta m is not 0, but in case of steady flow process, delta m is 0 because mass flow rate that enters into control volume पर सेकेंड में अगर 15 kg मास एंटर करेगा तो 15 kg भी लीव कर जाएगा in case of steady flow process, ताकि mass of the control volume remains constant. But in this case mass does not remain constant. So if mass remains constant means delta m 0, but in this case unsteady flow process में delta m 0 नहीं होगा, कुछ accumulation या reduction हो जाएगा. जब ओनली मास इन नहीं होगा, ओनली डिस्चार्जिंग होगा, अगर ओनली एम आउट होगा, मास ओनली निकल के जाएगा, कोई मास आएगा नहीं, तो ऑब्वियसली डेल्टा एम विल बी नेगेटिव, मास तो घट जाएगा. जो इनिशियल मास होगा कंट्रोल वॉल्यूम में वो तो घट जाएगा. देयर विल बी अ डिक्रीज इन द मास ऑफ द कंट्रोल मास कंटेंट ऑफ द कंट्रोल वॉल्यूम. सो दिस इज द mass balance equation, and I can write like this is m final, delta m is nothing but m final minus m initial of control volume, and we can take this to be m2 minus m1. So you must be clear about this notation. m in means जितना mass enter करेगा over that finite period of time delta t. m out means जितना mass exit करेगा over that finite period of time, and which is equal to delta m of control volume. Over that finite period of time, what is the change in mass of this control volume, this fixed area, this space, this fixed region. So m2 minus m1, m2 होगा फाइनल मास, m1 होगा इनिशियल मास. अगर and in this equation, suppose I will take this equation 1, and during the analysis sometimes one or more terms can be 0. Suppose for example in case of a charging, what happens, you see here, in case of charging there is only mass entering into control volume, no mass is leaving. Here only supply line से fluid आ रहा है ना यहाँ, लेकिन नो मास इज लिविंग, कुछ तो लीव नहीं हो रहा है. तो ये इक्वेशन में ये जनरलाइज्ड इक्वेशन है, एंड फॉर दिस केस एम आउट विल बी 0. सपोज दिस चार्जिंग ऑफ एन इवाक्वेटेड वेसल, सपोज बिफोर चार्जिंग यहाँ कुछ भी फ्लूइड नहीं है, मतलब ये इवाक्वेटेड वेसल है, रिजिड है, मतलब but evacuated vessel है. Evacuated vessel means m1 will initial mass of the control volume will be 0, and अगर if it had been a case of discharging, then m in would have been 0 but m out would not be 0. So accordingly, depending upon the situation, we have to make the analysis. So most of the times out of these terms, one or more terms may be 0. And in case of a rigid vessel, charging of a rigid vessel, there cannot be any boundary work present, because rigid means volume will remain constant. So how can there be any boundary work present? So next is energy balance. Energy balance. Energy balance. Energy balance. You see, suppose this is your control volume. यहाँ अगर कुछ एनर्जी जा रहा है ओवर ए फाइनाइट पीरियड ऑफ टाइम, या एनर्जी बाहर आ रहा है, तो हमारा ये सेम प्रिंसिपल विल अप्लाई. ई इन माइनस ई आउट इक्वल टू डेल्टा ई ऑफ कंट्रोल वॉल्यूम. डेल्टा ई ऑफ कंट्रोल वॉल्यूम, ये होगा सपोज योर इक्वेशन 2. सो ई इन जो ई आउट होता है, इन केस ऑफ एन ओपन सिस्टम, ऑन स्टेडी फ्लो प्रोसेस हो या स्टेडी फ्लो प्रोसेस, बोथ आर फॉर ओपन सिस्टम और कंट्रोल वॉल्यूम. ये जो एनर्जी इंटरैक्शन होता है, एनर्जी जब आता है एंड एनर्जी जब बाहर जाता है, इट अकर्स इन 3 फॉर्म्स, आइदर इन टर्म्स ऑफ हीट और इन टर्म्स ऑफ वर्क और along with mass. जो fluid, जो mass of the fluid that enters into the control volume also carries some energy with it. We have already studied that is called flow. Flowing fluid के साथ कुछ energy होता है. We have already discussed that. Flow work भी होता है, and apart from that certain other energies are also there. Flowing mass के साथ कुछ energy आता है, and flowing mass के साथ कुछ energy भी बाहर जाता है. और दिस डिफरेंस, वट एवर एनर्जी एंटर करता है, सपोज टोटल हीट एंड वर्क भी आता है. हीट एंड वर्क तो बाउंड्री फेनोमेनन है, वो तो बाउंड्री में इंटरेक्शन होगा. एनर्जी इंटरेक्शंस कैन टेक प्लेस अक्रॉस द बाउंड्री. दे आर प्रेजेंट इन बोथ इन केस ऑफ क्लोज सिस्टम एंड ऑल्सो इन ओपन सिस्टम, वो भी होगा. एंड अलॉन्ग विद दैट some energy interaction will also take place. Some energy will flow with the flowing fluid into the control volume, and some may leave the control volume with the exiting fluid. So that may take place. So this term you may take net energy transfer. This you can say net energy transfer. Net energy transfer by heat, work and mass. ये जो मास आता है उसके साथ भी कुछ एनर्जी आता है. नेट एनर्जी मीन्स इतना आता है और ये बाहर जाता है, तो नेट कितना आ गया कंट्रोल वॉल्यूम को, इतना ही आ गया. ई इन माइनस ई, वो जाके क्या करेगा, ये चेंज लाएगा, कंट्रोल वॉल्यूम का एनर्जी में चेंज लाएगा. डेल्टा ई ऑफ सी बी रिप्रेजेंट्स द चेंजेस इन, जैसे कि हम डिस्कस किए, ई इज द समेशन ऑफ ई के, ई पी एंड यू, molecular internal energy. So changes in internal, U is internal, kinetic is EK, and potential energy. So ये जाके जो जितना नेट एनर्जी आ गया, वो जाके कंट्रीब्यूट किया डेल्टा ई ऑफ, दैट रिजल्ट्स इन डेल्टा ई. डेल्टा ई में भी पॉजिटिव और नेगेटिव, दैट डिपेंड्स अपॉन दिस वैल्यू. सो चेंजेस इन, ये जो कंट्रोल वॉल्यूम का जो एनर्जी कंटेंट है, दैट इज डेल्टा ई रिप्रेजेंट चेंज इन एनर्जी कंटेंट ऑफ द कंट्रोल वॉल्यूम. एंड ये जो है, ये नेट एनर्जी ट्रांसफर बाय हीट और वर्क और विद द फ्लूइड मास ऑफ द फ्लूइड. सो अगर हम इक्वेशन डिराइव करेंगे, सपोज यहाँ हमारा, सपोज ये हो गया हमारा सी बी कंट्रोल वॉल्यूम. यहाँ क्यू इन भी हो सकता है, और 2 जो सेक्शन होता है, एक होता है इनलेट और आउटलेट. क्यू इन इज पॉसिबल, क्यू आउट इज पॉसिबल, एंड डब्ल्यू इन इज पॉसिबल और डब्ल्यू आउट इज पॉसिबल. But in most of the books you will find that heat is assumed to be flowing into the control volume and work is assumed to be flowing out of the control volume, or work is done by the system. Heat is input to the system and work is done by the system. ऐसा conventionally लिया जाता है, लेकिन हम ऐसे भी ले सकते हैं, we can assume that there may be cases where Q may be rejected by the system and there may be cases when work is done on the system. So to encompass all those possibilities, to include all those possibilities or all those situations, what we can do is we have to take all these things into account while deriving the equation. So suppose इनलेट पे मास आ रहा है m in and आउटलेट पे मास जा रहा है m out. So equation will be E in will be Q in plus Q in plus M W in भी होगा. So whatever ये जो इक्वेशन में लिखे थे हम सेकेंड इक्वेशन में E in माइनस E out, ये वाला इक्वेशन में ये देखो E in माइनस E out. E in मतलब जितना एनर्जी एंटर कर रहा है टोटली, whatever energy is enter into control volume, we will take that into account. Maybe there may be Q in and there may be W in. W in मतलब conventionally हमको negative sign में put करना पड़ेगा. When work is input into the system, it is taken to be, conventionally we take it to be negative, but this is an energy entering into control volume plus, suppose M in is the mass that enters into the control volume over that finite period of time. हम अभी ओवर ए फाइनाइट पीरियड ऑफ टाइम एनालिसिस कर रहे हैं. वी आर नॉट एनालाइजिंग इन टर्म्स ऑफ रेट ऑफ फ्लो ऑफ मास. वी आर मास m in represents the total mass of fluid and that has entered into control volume over a finite period of time. Theta is the energy of flowing fluid per unit mass. Energy of flowing fluid per unit mass ये हो गया हमारा E in. और E out में क्या रहेगा? Q in, Q out. वो suppose there may be cases when Q may go out of the control volume. Q out plus W out plus M out theta. M out theta. इसको हम थीटा इन थीटा आउट ले सकते हैं, इज इक्वल टू ई इन माइनस ई आउट इज इक्वल टू डब्ल्यू इन, सॉरी ई इन माइनस ई आउट इज इक्वल टू डेल्टा ई ऑफ द कंट्रोल वॉल्यूम. डेल्टा ई जो होता है, ये जो ई होता है ई के प्लस ई पी प्लस ई, एनर्जी कंटेंट ऑफ दिस कंट्रोल. ये तो एनर्जी इन हो रहा है, ये आउट हो रहा है, लेकिन ये जो डेल्टा ई है कितना बढ़ गया या घट गया, तो चेंजेस इन द एनर्जी कंटेंट. सो व्हाट इज द एनर्जी कंटेंट ऑफ द कंट्रोल वॉल्यूम? वो तो होता है ना, एनर्जी कंटेंट ऑफ द कंट्रोल वॉल्यूम विल बी हाउ मच? M2 E2 minus M1 E1 ऑफ कंट्रोल वॉल्यूम. ये भाई कहाँ से आ गया? M2 E2 माइनस M1 E1. यू नो E2 इज द स्पेसिफिक एनर्जी पर यूनिट मास का, ये स्पेसिफिक एनर्जी है पर यूनिट मास का. 1 kg मास का ये E2 होता है स्पेसिफिक एनर्जी. एंड E2 इज U2 प्लस के ई, सपोज हाफ M2 V2 स्क्वायर U2 प्लस ये पोटेंशियल एनर्जी भी होता है. सो M2 E2 पर यूनिट मास का एनर्जी, एंड ये मल्टीप्लाई करने से M2 से E2 कैपिटल E2 आता है. ये मास फाइनल मास, जब मास इंटरेक्शन हो रहा है उसके बाद जो फाइनल मास होता है, ये OM2 होता है, ये इनिशियल मास ऑफ द कंट्रोल मास विद इन द कंट्रोल वॉल्यूम कितना था इनिशियली, दैट वाज M1 एंड आफ्टर इंटरेक्शंस हैव टेकन प्लेस, क्योंकि चेंजेस आ रहा है ना, मास एंड इन एनर्जी एनालिसिस ऑफ अनस्टेडी फ्लो प्रोसेस, व्हाट वी डू इज वी हैव टू कीप ट्रैक ऑफ द चेंजेस दैट ऑकर टू बोथ मास एंड एनर्जी कंटेंट ऑफ द कंट्रोल वॉल्यूम। मास कंटेंट में भी चेंज आ रहा है, M1 था इनिशियली, M2 हुआ फाइनली, एंड एनर्जी कंटेंट जो E1 था इनिशियली, E2 आ गया। सो इसलिए वो डिफरेंस को हम निकालना पड़ेगा। सो M2 is the mass of the control volume after the interaction, after the process is taken place, and M1 was the initial mass. And if it, as a special case, suppose initially the vessel was evacuated, means this term will be eliminated, M1 will be 0. So this is the equation, M2E2 minus M1 E1। अगर हम इसको रीअरेंज करेंगे, सपोज दिस इज योर इक्वेशन 3, अगर हम इसको रीअरेंज करेंगे, सो Q in माइनस Q आउट माइनस W आउट माइनस W in, ऐसे लिख सकते हैं, देयर इज नो प्रॉब्लम इन दैट। Q in माइनस Q आउट माइनस W आउट माइनस W in प्लस M in theta in minus M out theta out is equal to M2 E2 minus M1 E1 CB कंट्रोल वॉल्यूम। हम इसको लिख सकते हैं Q इन कितना हुआ और उससे कितना बाहर चला गया हीट, मतलब वो नेट हीट इनपुट हम Q नेट लिख सकते हैं। Q नेट जो हम लिख सकते हैं नेट हीट इनपुट माइनस ये वाला को हम लिख सकते हैं नेट W नेट वर्क आउटपुट हम लिख सकते हैं। सो ऐसा लिखने से क्या एडवांटेज आएगा हमको, where there will be some cases when there will be heat rejection, so that will be taken care of. But it is not right to think that only heat will enter and work will go from the system or control volume. That is usually that convention is adopted, but this is the proper way to analyze Q net. Whatever, suppose there are two interactions, in case heat input is taking place and heat is being added to the control volume and heat is also being rejected from the control volume. So we will find out that Q net. Accordingly, we will find out the W net, net work output is equal to M2E2 minus M1U1 of control volume plus M out theta out minus M in theta in. And E2 and E1 comprises of three terms, EK, EP and U molecular internal energy. एंड थीटा में क्या क्या टर्म है, थीटा में भी ये है, थीटा जो एनर्जी ऑफ ए फ्लोइंग फ्लूइड वो है H प्लस बी स्क्वायर बाई 2 प्लस GJ। स्पेसिफिक एनर्जी ऑफ फ्लोइंग फ्लूइड पर यूनिट मास में ये सब है, H है बी स्क्वायर बाई 2 प्लस GZ। अगर हम चेंज इन काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी को नेग्लेक्ट कर देंगे, क्योंकि ये जो एनर्जी टर्म होता है विथ रेस्पेक्ट टू H ये बहुत ही नेग्लिजिबल होता है। सो इफ वी नेग्लेक्टिंग चेंजेस इन काइनेटिक एनर्जी and the potential energy of both control volume and flowing fluid। सपोज कंट्रोल वॉल्यूम में भी कुछ चेंज हो सकता है, काइनेटिक कंट्रोल वॉल्यूम तो मूव नहीं कर रहा है, तो कंट्रोल वॉल्यूम में कुछ चेंज यूजुअली नहीं होता है। काइनेटिक एनर्जी और पोटेंशियल एनर्जी में कंट्रोल वॉल्यूम में भी ज़्यादातर केस में चेंज नहीं होता है, और जो फ्लोइंग फ्लूइड यहाँ जो आता है और यहाँ जाता है उसमें भी चेंजेस इन काइनेटिक एनर्जी और पोटेंशियल एनर्जी कैन बी नेग्लेक्टेड इन मोस्ट ऑफ द केसेस। सो अगर ये हम नेग्लेक्ट कर देंगे, सो दिस इक्वेशन विल रिड्यूस टू Q net minus W net is equal to M2 U2 minus M1 U1 CV M2 U2, क्योंकि E जो होता है ना ई के प्लस ई पी प्लस यू, ई जो होता है ई के प्लस ई पी प्लस यू, जो अगर ये दोनों टर्म का नेग्लेक्ट कर देंगे तो ई विल बी यू, मॉलिक्यूलर इंटरनल एनर्जी रहेगा। तो M2 U2 माइनस M1 U1 कंट्रोल वॉल्यूम प्लस M आउट H आउट माइनस M इन H इन। जो फ्लूइड जो आउट हो रहा है, एग्जिट हो रहा है, उसका जो स्पेसिफिक एंथैल्पी है, जो फ्लूइड स्ट्रीम जो आउट हो रहा है उसका स्पेसिफिक एंथैल्पी, and the mass of the fluid stream that is leaving, that is M out, and this mass of the fluid entering into the control volume with this H in represent the specific enthalpy of the fluid that is entering into the control volume. So ये हो गया हमारा इक्वेशन। ये सपोज हम ले लेंगे इक्वेशन, this is that was your equation number 3, suppose this is your equation number 4. सो यहाँ अगर कुछ केस में इंसुलेटेड होगा, अगर सपोज द वेसल इज इन केस ऑफ चार्जिंग द वेसल इज इंसुलेटेड, सो मतलब नेटवर्क आउटपुट तो जीरो होगा ही होगा, क्योंकि इंसुलेटेड है मतलब देयर कैन नॉट बी एनी हीट इंटरेक्शन टेकिंग प्लेस बिटवीन कंट्रोल वॉल्यूम एंड सराउंडिंग। एंड जैसे कि हम ऑलरेडी डिस्कस कर चुके हैं कि अगर इनिशियली द वेसल वाज इवाक्वेटेड, दैट मीन्स M1 टर्म विल बी जीरो। And in case of charging, suppose this is an example of charging, ये charging में only M in is there, no M out is there, so M out, in that case I will reject, I will neglect that M out term and that will be reduced to zero. Accordingly we have to take the initially अगर evacuated तो initial mass of the control volume is zero, M1 represent the initial mass of control volume, M2 represent the final mass of control volume, मतलब ये हुआ हमारा कंट्रोल वॉल्यूम। इसमें ये चार्जिंग होने से पहले कितना मास था, सपोज 10 kg था तो M1 हुआ 10 kg। आफ्टर चार्जिंग सपोज मास इंक्रीजेस टू 15 kg तो M2 होगा हमारा 15 kg, and that 5 kg is nothing but M in minus M out, क्योंकि हमारा मास बैलेंस इक्वेशन में ये आ गया M in minus M out is equal to M2 minus M1। But if suppose in a problem it is given that initially the vessel was evacuated, means there was no mass inside the vessel, so M1 was 0, and in this case M out is 0, क्योंकि कोई भी मास यहाँ से निकल के नहीं जा रहा है, only mass is entering into the control, M in is there, M in is there in case of charging, no M out is there. And if the vessel is insulated, there cannot be any heat transfer possible, so Q net we have to take 0. And if the vessel is rigid, boundary work will not be there because volume is constant. If it is given that some shaft work is there or electrical work is there, that can be taken into account, but no boundary work will be there in case of rigid vessel. So this is the most general equation from which according to situation we have to analyze and put there will be situation, there will be definitely some cases when some terms out of the general equation will be reduced to 0 to make your analysis convenient, because two types का problem आता है, one is charging and discharging. In case of charging there will be no M out, only M in, obviously this term will be reduced to 0, and in case of discharging only M out will be there and no mass will enter in, so this term will be reduced to 0. And if it is evacuated, M1 will be 0, and if it is insulated, Q net will be 0. So this is the most general equation, that is Q net, net heat input minus net work output or net work done by the system and this is net heat input to the system or control volume is equal to m2u2 minus m1u1, where m1 is the initial mass of the control volume, m2 is the final mass of the control volume. इनिशियल मीन्स प्रोसेस होने से पहले कितना मास था, और प्रोसेस after the process has taken place for a specific period of time, suppose delta t, what is the mass? And obviously there will be m2 will always be different from m1, but in case of had it been a steady flow process, m2 will be same as m1 because m in will be equal to m out. So mass balance अगर लगाओगे तो कोई भी मास एक्यूमुलेशन नहीं होता है स्टेडी फ्लो में, यहाँ वो होता है. तो डिफरेंस इज दैट in case of unsteady flow process we have to keep track of what are the changes that occur to both mass and energy content of the control volume, and apart from that energy interaction that take place across the boundaries also are to be taken into account. So that makes analysis a bit complex, but if you understand it, then the concept is very easy. So that's all.